Every day you rely on them to start your car, power your phone, and keep your laptop running. But if I asked you to explain what's actually happening inside a battery, could you do it? Most people think batteries store electricity, like a tank holds water. But that's not quite right. A dead battery isn't empty of electricity, it's just chemically exhausted. In the next few minutes, we're going to crack open the black box of the battery. You'll learn about the redox reaction that powers your life, the difference between a lithium-ion and a lead-acid battery, and why, for the first time in history, we are using these devices to save the planet from climate change. Please support this channel by just subscribing. That would mean a great help. Let's charge into it. To understand a battery, we have to ignore the plastic casing and look at the chemistry. A battery is simply a device that uses a chemical reaction to push electrons through a wire. The specific type of reaction is called an oxidation-reduction reaction, or redox for short. Here is the rule. One material loses electrons and another material gains them. When a material loses electrons, we call it oxidation. When it gains electrons, we call it reduction. Think of it like a game of hot potato. If you force an atom to give up an electron, that electron has to go somewhere. Inside a battery, we separate these two materials, so the electrons are forced to travel through a wire to get to the other side. That flow through the wire is what we call electricity. This setup is technically called a galvanic or voltaic cell. The metal that gets eaten away, the one losing electrons, is the anode, or the negative terminal. The metal that gains the electrons is the cathode, or the positive terminal. But here is the trick question. If the electrons travel through the wire, what happens to the atoms that lost those electrons? They become positively charged ions. If they build up, they'd repel the reaction and stop it instantly. That's where the electrolyte comes in. The electrolyte is the chemical soup inside the battery. It allows charged ions to move between the anode and the cathode to balance the charge. While the electrons go the long way around the wire, powering your phone, the ions travel directly through the electrolyte. This double flow, electrons on the outside, ions on the inside, is the only way a battery works. Cut the wire, the electrons stop. Dry out the electrolyte, the ions stop. Either way, the battery dies. This brings us to the biggest distinction in battery science: primary versus secondary batteries. A standard alkaline AA battery, like the ones in your TV remote, is a primary battery. In an alkaline battery, the zinc anode is literally being consumed to make the reaction happen. Once the zinc is used up or the electrolyte dries out, the reaction stops. It's a one-way street. You can't uncorrode the metal easily, so you throw it away. But a secondary battery, like the lithium-ion cell in your phone, is reversible. When you plug your phone in, you are forcing the electrons to go backwards. Instead of the anode pushing electrons out, an external charger forces the electrons back into the anode. This undoes the chemical reaction and resets the battery for another cycle. This is why lithium-ion batteries can last for hundreds or even thousands of cycles. To see these principles in action, let's compare the two most common batteries on Earth, the lead-acid in your car and the lithium-ion in your pocket. First, the car battery. When a lead-acid battery discharges, the lead and lead dioxide react with sulfuric acid to create lead sulfate and water. This creates a massive surge of power, enough to crank a frozen engine. But lead is heavy, and the chemistry is slow to recharge. On the other hand, lithium is the lightest metal in the universe. In a lithium-ion battery, the lithium ions shimmy back and forth between a graphite anode and a lithium metal oxide cathode. Because lithium is so light, Lithium-ion batteries pack about 5 times more energy into the same amount of weight as lead acid. That's why your phone fits in your pocket, but your car battery requires 2 hands to lift. So here is the bottom line. A battery isn't a bucket of electricity. It's a sophisticated chemistry lab where we force electrons to flow from an anode to a cathode through a wire. We started with the simple redox reaction. We moved through the reversible chemistry of lithium-ion. And now, these same principles are being scaled up to solve the biggest problem of our generation, climate change. By storing solar energy in massive battery farms, we can keep the lights on even when the sun isn't shining. Thanks for watching. And don't forget to subscribe, like, and share.